Okay, Form 4 Astronomy, welcome to Lesson 36. Today's question of the day, how do we even know how big stuff like the Earth is? Now, the Earth is big, but how do we know how big? How did we actually figure that out? Well, that's the sort of thing we're going to be looking at in today's lesson. I'm going to post this PowerPoint so that you can do things like go and watch these YouTube videos separately afterwards. I'll post the PowerPoint and the associated materials as normal. So today's title is Diameters and Distances, still in topic 3, the Earth, Sun, Moon system. I'm going to assume you're going to pause the video as you need for note-taking, or you might do note-taking separately from the PowerPoint itself. All right, so check this guy out. This guy is called, wait for it, I can never say his name, Eratosthenes? Eratosthenes. Every year I forget how to say this. Eratosthenes. No, Eratosthenes, maybe. He was an ancient Greek from about 200 BC, and he was the guy who figured out how to calculate the circumference and the diameter of the Earth. So, what did he do? Well, he lived over here in Egypt, and he came up with the science experiment that he could do that would actually figure out how big the Earth was. So what he did, basically, he was in a place called Syene. So if I go back, Syene's down south here. What's interesting about Syene is that it's pretty much, if I remember rightly, it's pretty much exactly at plus 23.5. So I can't remember if it is, but it's really, really close. Basically, it does indeed have the sun overhead in the summer. And by overhead, I mean directly overhead. So what we can see is, like, if you go down to a deep well and stand at the bottom, the sun is directly above you. You can only see the sun when it is exactly midday. The other thing you could notice is that things like poles and columns, they didn't have shadows, right? Because the sun is directly above them. This told us that the sun was directly overhead in Syene. Now, Alexandria, which is a little bit further north, doesn't have the sun directly overhead. So our vertical poles cast a shadow. And what Eratosthenes figured out was that you could maybe measure the angle here between the sun and the vertical. And that angle there measured as 7.2. Let's go back. Where was Alexandria? So we had Syene down here and then Alexandria up here. Okay, cool. So here's another diagram. You could have a meter rule and you could kind of think about this, right? You could measure the length of this shadow. If you knew the length of this, you could use trigonometry to work out this angle right here. So this is effectively what Eratosthenes had. He had light shining vertically in Syene, so straight down a well, and he had light casting a shadow in Alexandria. Now, if you look here, this is actually a Zed angle from maths. I think they're not called Zed angles anymore. They're called equivalent angles, or you can tell me, I'm sure. But there's a Zed angle, and so we can see that if we know this angle right here, we actually know this angle right here. So we know the angular distance between Syene and Alexandria. So that's pretty cool. What can we do with that? Well, he measured it to be about 7 degrees. What we need next is to know how far away Alexandria to Syene is. Now, what I want to do is maybe draw on here. Can I draw? Yeah, cool, I can. So I'm going to draw and see if it works. So if we could measure this distance right here, and we know this angle, then you might realise, can we change the colour? Oh, very good. Then you might realise that, well, if we know that distance and that angle, maybe we could figure out this whole distance, the circumference of the Earth, because we know this whole angle is 360 degrees. So there's a ratio here, isn't there? A ratio. Now, how do I go back to not doing this stuff? No idea. Let's click forwards. Okay, cool. And I'm still drawing. I have no idea. It's going to be drawing forever. How do these work? This one? No. This one? No. Click pen again. Yes, good. Okay, so think about this ratio, right? Circumference of Earth divided by the distance from Syene to Alexandria is the same as 360 degrees divided by 7 degrees. So if you think about this, if he measured this distance, he could work out the circumference of the Earth. That's amazing. Oh, Allow, I guess. Oh. No way! It does subtitles by itself. That's so cool. Okay, how do I turn that off? There we go. Alrighty. So this is basically the picture that we have. Here's another version of it. Now, what we don't know is how he measured the distance between Syene and Alexandria. We might have had an army of men pacing it out, or he might have counted like wheel rotations of a carriage driving between the two cities. This is my photoshopped picture of Eratosthenes with his trundle wheel. There's a video there you can watch if you have time. And that is it for Circumference of the Earth. That is everything you need to know. I am going to finish that video there and check back in for the next section, relative diameter of the moon.